So, I'm very pleased to be able to invite Elpida from IBM up onto the stage. Elpida is an IBM Fellow and the CTO of the IBM AI on Z project products.
Yeah, I'm leading the mission.
Oh, leading the mission. Wow. Elpida, welcome and thank you very much for taking the time to do this.
I don't know, and welcome everybody, if I'm going to be as jolly as Mark. I mean, he was holding a Guinness in his hand, and I don't have one up here, so. Is that how they do things here in the UK? Yes. That's great. So welcome everybody. I'm Elpida Georgatos. I know Mark didn't attempt my last name, and I got to tell you, I'm known mainly by my first name, like Cher and Madonna, so I'm Elpida. And what I wanted to talk to you about today is really AI. I've been leading the AI mission on IBM Z for about the last 4 to 5 years now. Of course, I grew up in Z, in ZOS specifically, so when I talk about AI and AI on Z, I'll be making references to ZOS, but really a lot of the AI capabilities and technologies that we deliver on IBM Z apply to all the operating systems that we support on Z, mainly ZOS, Linux on Z, as well as in ZOS container extensions with ZOS. Now, with the advent of ChatGPT about a year ago, in November of 2022, the world really realized the potential and the power of AI, not only in the consumer space, but also in the enterprise space. ChatGPT showed the world what AI could be capable of. And you can say that we are really at an inflection point in terms of AI in the IT space and in the IT technology space, in terms of AI within the next 3 to 5 years is really going to transform how we work, how we do business, and really our everyday lives, as well as the skills that we bring into the workplace as well. And I wanted to start with a light joke. As I said earlier, a lot of my presentations are a matter of fact and a little bit dry, so I asked ChatGPT a couple hours ago to write, given that I'm in the UK, as experience sonnet about Elpida presenting at the GSC in the United Kingdom. And this is what it came up with. Now, I'm not going to read it all, but at the bottom, I read the last 2 lines there, and it says, "A master of the mainframe, our diva." And I thought to myself, diva? Really, me? You know, I'm a very humble person and very approachable person. And at least in the United States, the word diva is usually used to describe very difficult women. It's almost synonymous with the B word, if you will, in the US. But I looked it up, and I guess diva also was used to mean a woman of great talent. So I'll take that as a compliment. But while ChatGPT is really great at silly things like this, really it's not ready, right? It's great in the consumer space, and what I say about ChatGPT is that it solves the blank page problem, right? If you don't know where to start with writing an email or even the outline, oh, thank you. Thank you. If you don't know where to start with responding to emails or writing the outline of your GSC presentations, is a great place to start, but it's not ready to be used in the enterprise. The technology that backs ChatGPT, which is really large language models and generative AI models that are built on this transformer architecture that I'll describe in the next couple of charts, is really very powerful, but it's not mature yet to be used in enterprises. There's a lot of dangers, right, with using ChatGPT in enterprises, and I'll speak to some of those. And certainly organizations and enterprises want to leverage this technology safely without having risks that really outweigh the benefits. I'm sure a lot of you have heard about how ChatGPT can hallucinate and fabricate and make up answers, and we're already seeing the news out there around lawsuits around some of the ChatGPT generated content. So from an enterprise perspective, it really is very, very important that you guys can use this technology safely, and a lot of the capabilities that we are delivering with watsonx at IBM is all about leveraging these technologies safely within enterprises. I wanted to share a couple of statistics with you. You can see here that AI and the use of AI within enterprises is really growing significantly, and you can see here in the last 5 years, enterprise adoption within organizations and enterprises has more than doubled. And in my opinion, if you look at where the world is going, enterprises and businesses that don't leverage AI and don't embrace AI are not going to be relevant in the next 5 to 10 years. Enterprises that do leverage AI are more likely to outpace and outperform the competitors in their respective industries. But before I started with describing the capabilities that we built on IBM Z to enable you to very easily embed AI into your mission critical workloads, really to make better, more informed decisions, or to detect new patterns, or to serve your clients and deliver a better client experience, I wanted to cover some of the basic terms, because I know a lot of people use these terms interchangeably, but if you look at the context of each of these terms, there's some nuances, and really using them interchangeably is not the correct format. So artificial intelligence is this broader overarching concept, and it really has to do with building machines, smart machines that are capable of performing tasks that are usually related with human intelligence. So that's the broader overarching concept. And then within that, you have machine learning that really refers to a set of techniques that allowed computers to be intelligent by learning from existing data, and with 1 or 2 training algorithms without having to explicitly program those algorithms. And then within machine learning, you have deep learning, which is really an area of machine learning that leverages AI algorithms, where the architecture of those AI algorithms really look like neural networks that connect neurons with our brain. So therefore, that's why they're called neural networks, and you hear the term deep neural networks because it refers to the number of layers that are hidden with those networks. And deep because a lot of times there's the input, many hidden layers that do a lot of mathematical computations in between, and then the output. A subset of deep neural networks or deep learning is foundation models. Foundation models was a term that was really coined by Stanford, and as the name implies, is really models that form the foundation on what other models can be built upon. Now, what's really new and revolutionary around foundation models is these are very, very large models that are self-supervised, and they're really trained on unlabeled data. So far, if you take machine learning and deep learning, those were algorithms that were really trained on labeled data, which can be very tedious, and it can cause and can create a lot of overhead for a lot of businesses, as well as elongate the time to value in terms of the time it takes to build these models and until the time it takes to deploy those models within applications and leveraging them from business critical applications. Now, foundation models are trained on general unlabeled data. They learn through self-supervision. And really, one of the key benefits around foundation models is that you can take this general model and then fine-tune it or customize it and adapt it to any downstream task. So therefore, you have faster time to value from the time it takes to build and develop the model to the time, because now you're taking that pre-trained model, you're customizing it with a smaller subset of your own data, and then you can customize it and adapt it to do a specific task or use case. So that is really the idea behind foundation models. And certainly ChatGPT is the foundation model. It's also a special kind of foundation models. Even within the foundation model family, if you will, you have large language models, and as the name implies there, these are models that understand language, and it's just not only English or French language or human language, but it can understand the language of code, for example, the language of chemistry, the language of physics. And within the large language model family, you have models that can generate new content, and those models are called generative AI models. Again, as the name suggests, they're called generative because they generate content, and these are models that can generate code snippets, can generate content summary, they can summarize news articles, for example, they can do language translation, they can perform they're really advanced, if you will, chatbots or chat apps that can act as expert advisors. So those are generative AI models. So you can think of these concepts that I just talked about, AI, machine learning, deep learning, foundation models, and even under foundation models, which I didn't put the details on this chart, large language models and generative AI models as Russian nested dolls, if you will. Now, from an IBM Z perspective, the trends that we're seeing, a lot of our clients, especially a lot of clients like you in the banking and financial services space, started with traditional AI. And what is traditional AI? If you look back in this chart, machine learning and deep learning, even though they're both fairly new within the enterprise space, are already called traditional AI since the advent of foundation models. So within the last year, since the advent of ChatGPT and generative AI, the industry started calling machine learning and deep learning type of AI models traditional AI. So if you hear that term, it really applies to machine learning and deep learning type of AI models. And then foundation models, which generative AI models is a subset of foundation models, is the new technology. But the trends that we are seeing within the industry, traditional AI models are not going away. There's a lot of hype around generative AI models because they have a lot of potential, and they're good for a certain number of use cases, right? They're good for HR type of use cases, talent use cases, expert advisor use cases. They're good for advanced chatbot type of use cases and code generation. But there's also another set of use cases which the specialized traditional AI models are really more adept or a better fit for. So what we see is that traditional AI continues to grow significantly and has a big traction, especially in the enterprise market. And I'll talk about some examples of traditional AI. We're also seeing generative AI and foundation models growing as well. So both traditional AI and generative AI will have a role to play in the enterprise space. And I'll talk about how both impact and are important for businesses. And then what I have in the middle there is this new term that we at IBM coined. It's called Assemble AI, which really is using multiple models to actually achieve better results, more accurate results, whether that is for fraud, whether it is for screening for anti-money laundering. What we're seeing now with a lot of clients is this emerging trend where they're using both a traditional AI algorithm in combination with a foundational model, not necessarily a generative AI foundation model. As I said earlier, there's different types of foundation models. And foundation models, many of you might have heard BERT. Foundation models that are not generative AI models can also be used in combination with traditional AI to improve the results of fraud detection, for example, anti-money laundering, claims processing. And now we're seeing a trend in our clients where they're using multiple models and they bring together traditional AI algorithms as well as foundation models. And I'll give you a couple of examples of that as well. I wanted to give you a quick review in terms of the capabilities that we delivered on IBM Z. And really, we've been working on AI for a few years now on IBM Z, but with the GA of IBM Z16, we really put ourselves on a map as an AI platform specifically for inference. And by inference, I mean deployment of AI models on our platform. We were really the first one in the industry to deliver a commercial enterprise AI accelerator that is integrated on a microprocessor chip. And what I mean by that, unlike GPU-like accelerators that are host attached or PCIe attached type of cards, our accelerator on the Z16, and by the way, you have more than one, right? There's one per chip, one per 8 cores. You can have up to 8 in a Z-Draw and up to 32 AI accelerators on a fully loaded IBM Z16 server. It's integrated right on the same silicon as your cores. And what does that mean? That means that it gives us really the advantage of being able to be optimized for very, very low latency and high throughput. What we heard from a lot of clients when we're designing this AI accelerator for IBM Z16, a lot of our clients, specifically the ones that had high volume transactional workloads, such as a lot of you in the audience here, told us that two of the biggest challenges, even though they had made tremendous investments in being able to train and develop some very sophisticated models, and some of those clients had also hired the best talent out there, both from academia and the industry, to help them develop these AI models. What they were starting to see was, even though they had these models that were delivered on the accuracy that they needed, when it was time to take those models and deploy them in their workloads, they couldn't do so because of their impact to their SLAs, right? By the time the model came back with a prediction, let's say a transaction had completed, or in order to be able to score or examine all of these transactions, every transaction with AI, it would slow down their application and it wasn't acceptable. And as a result of that, a lot of clients told us, not only Z clients, but I'm talking about the broader client set, because we really worked with and surveyed and did research with Z as well as non-Z clients that were trying to embed AI into their mission critical enterprise workloads. A lot of the clients told us because of that, at the time in the industry before we GA'd Z16 was such that most clients were only able to sample about 10% or less of their transactions with AI. So we designed this accelerator on the chip. So not only accelerates a lot of the complex linear algebra type of math and computing mathematical operations that are invoked when those models are invoked from applications to make a prediction, but the fact that our accelerator is integrated right on our microprocessor chip gives us the ability to optimize, as I said, for very, very quick response times and high throughput, because we don't have to move the model itself and the input to that model from the host memory down to the device-specific accelerator memory, which is the case if you have host-attached PCIe sort of AI accelerators. So we benefit by the many, many innovations that we made in accelerating a lot of the matrix algebra math operations that are needed as part of computing the AI inference or the predictions the models do, but also the fact that we have that microprocessor, that accelerator sitting right on the microprocessor chip. As I said, we minimize data movement, which really gives us an advantage over other accelerators. And I'm not going to read all the data on the chart, but you can see we can process up to 300 billion deep learning inference requests per day. And if you do the math, that works out to 3.5 million per second. So we build an accelerator not only to meet a lot of your today's needs, but also to anticipate your future growth as well. One thing that I do want to point out is from a sustainability perspective and an energy consumption perspective, and I know that for a lot of you in the EU, energy costs have, dramatically increased. Our accelerator is much, much more, energy efficient than other accelerators out there. And you can see that we run this benchmark of running AI workloads on the IBM Z16 server and comparing that, running the same AI workload on an x86 server with a GPU, and we are 41 times more efficient in terms of the energy consumption on Z16 versus other accelerators. And you can see that because our accelerator adds about 7 watts on that chip versus the 300 to 700 watt range for GPU-like accelerators. Now, from a broader AI perspective, it's not only about building AI hardware acceleration, but what we really focused on doing is making it easy for you to embed AI into your mission-critical applications. And to do that, we built a very robust AI ecosystem that embraces a lot of the open source frameworks and tooling, AI frameworks and tooling from the open source ecosystem, as well as our own offerings. And if you look at the left-hand side, some of our own offerings is Watson Machine Learning for z/OS. Now, Watson Machine Learning for z/OS, we've taken the Watson technology and really tailored it for z/OS environments. So it's just as easy to add AI to COBOL, to existing COBOL and PL1 and assembler applications, as it is to add that AI to Python and Go and Java applications. It was very important to us that with minimal application changes, all of you guys are able to invoke state-of-the-art AI into your COBOL applications while transparently benefiting from the hardware acceleration capabilities that we added to our IBM Z servers. If you prefer open source, because a lot of your data scientists or your application developers are very familiar with open source and know and love open source AI and frameworks and tooling such as TensorFlow or Apache Spark or for example, PyTorch, you have those frameworks available on Z. And not only have we ported those AI frameworks and tooling from the open source to IBM Z, but we have optimized them and instrumented those frameworks so they can transparently leverage the optimizations and accelerations that we've put in the underpinning layers of our stack. And I'll give you a couple use case examples of clients where they used machine learning to embed AI into their applications, and other clients who used actually open source to do so, and why. And then on the right-hand side, what you're seeing is we're also putting significant investments in leveraging AI within our own systems to deliver client value to clients such as yourselves. Some of the things we're doing, obviously, in the AI app space, which I won't talk about a lot today because we don't have time. I'll focus on the business use cases. But we invest in a lot in AI apps where we leverage AI to really help you enhance the resiliency of your IT systems, reduce mean time to recovery, and get to problem resolution a lot faster. We're also looking to leverage AI in the data privacy and data security space, and we'll continue to deliver innovations in that space as well. And then obviously within z/OS, with z/OS 3.1, we started to leverage AI within WLM to help you manage batch workload picks by automatically starting and stopping WLM managed initiators based on workload demand. And you'll continue to see us to invest more in leveraging AI and z/OS to simplify the management and configuration and tuning of our z/OS systems. Now, very quick, 3 things that we focused on was obviously hardware acceleration, because we wanted to make sure that we provided you with the speed and the scale that you needed in order to scale your applications for AI. And what you see there in the second column, and even most importantly, it was very important for us, as I said earlier, to ensure that you can consume AI very, very easily within your applications, and also get the production qualities of service and the strengths that the IBM Z platform provides. As I said earlier, we really support these AI capabilities in both on the Linux side, all the Linux distributions that we support on IBM Z, but as well in ZOS. And then we optimized a lot of the libraries and packages that are very commonly used with AI, such as OpenBlast. We developed our own deep learning compiler, which really gives you the ability to bring any model from any platform, and we'll compile it with you transparently if you're using Watson Machine Learning for ZOS, because we integrated our compiler within Watson Machine Learning on ZOS, or you can do the compiles, do it on your own, do the compile yourself. And what that would produce is actually you can take any model in the ONNX format, compile it with this deep learning compiler that we have available both on the Linux side as well on the ZOS side, and integrate it in Watson Machine Learning for ZOS, and it will produce a Z-optimized executable inference program that then an application can call, already leveraging the accelerator. So you don't have to worry yourself about the nuances of the hardware architecture of that accelerator. We have built the instrumentation either into our own products offerings or even into open source like TensorFlow. So if you're running a model, if your data scientists say, I want to deploy this model in TensorFlow or TensorFlow serving on ZOS, they can do that without any changes, and then it will transparently leverage that hardware accelerator if it's running on Z16. We've made it that simple. And then even with our own product offerings, as I said earlier, the exploitation of that hardware acceleration is also transparent because we build those optimizations in those product offerings. And then third, and also very, very important, we knew that a lot of you had made investments in training your models on Z or on other platforms on the cloud or on distributed. And we wanted to make sure that you leveraged those investments in the most efficient way, such that really the ecosystem stack that we invested in, and I mentioned ONNX, which is an open format for representing AI models, that you can take the models that you've built on any platform, on the cloud, on distributed, or in any framework, right? Whether it was TensorFlow or PyTorch or any other of the frameworks out there, and you can bring it to Z and deploy that model on Z close to your application runtimes to get the best scalability, resiliency, availability, and security that IBM Z provides. So not only can you train a lot of the machine learning and deep learning models on Z, you can bring any model from any platform and any AI model developed in any framework and very easily deploy it on IBM Z and call it from a COBOL application in a very easy manner. And I know there's a lot of sessions during this GSC conference that will go into deep details in terms of, I know Steve Warren has one tomorrow, and I know there's another one at IMS as well, that really show you step by step on how easy it is to do this. Now, one of the most innovative technologies that we've done, and it goes to, again, that theme of having AI that's easily consumable from Z applications. We built this technology called SQL Data Insights into DB213 right into the DB2 engine. And what you do is you point us to the DB2 tables of use that you want us to train a model on, and actually we'll train it under the covers. And that, along with some built-in functions that we provide in DB2, similarity, dissimilarity, clustering, and analogy, allow you to discover new insights from your DB2 data, right? And in a very easy manner. You don't have to know anything about data science, right? Because we do the data science and the training of the model under the cover. And some of the examples of some of the things you can do, you can say, I know Alpida, is involved in money laundering transactions. what other clients might have similar patterns as Elpida, and therefore I need to take a look at, because they also may be involved in doing illicit and money laundering transactions. And you can see here on the third column how you can do this similarity. You can do that very easily with this AI similarity SQL semantic query. We were the first in the industry here to provide similarity search for relational databases. So really, really powerful and innovative technology that we've built right in DB213, and it's very, very easy to use from DB2 applications. Now, I'm going to spend quite a bit of time talking about some of the use case examples, but I wanted to share with you some business statistics around the cost of fraud in the banking and financial services sector, but I also wanted to talk about, and cost of fraud in terms of transactions, whether it's payment transactions or credit card transactions, as well as AML, right? And the cost for IML, if you're not, you know, regulators and auditors come around and they decide that you're not doing due diligence in terms of AML screening, it can result to very big fines. But also, on the flip coin of that, a lot of the existing anti-money laundering techniques have a very high false positive rate, and a bank has to really investigate each and every one of those alerts. So it creates a lot of overheads for banks, especially if those alerts are false positive. So clients are looking to leverage, and we're working with a lot of our clients to help them actually reduce those false positive rates for anti-money laundering screening, as well as improve the true positive rates, right? You want to make sure that you do recognize illicit transactions. From a credit card perspective, we know that there's a lot of fraud, and that fraud is increasing as the number of online transactions continue to increase. And at the same time, false credit card declines also have an impact on revenue. Now, I'm going to share with you a few use cases that we've seen with clients, but AI has a broad applicability to a wide set of use cases across many, many, many different industries. And you can see here from banking to finance to trading to insurance and many other examples. But what I'm going to focus on for the next few minutes is actual use cases, and some of the use cases I wanted to highlight, and hopefully some of them will resonate with you, that we actually have worked with clients on, where certainly IBM Z is a core key component of our clients' hybrid cloud infrastructure, and I'll talk about what the benefits are that those clients saw from leveraging AI on IBM Z. And I'm actually going to start with two on the right-hand side here. Fraud detection, because certainly that's a very common use case we see with a lot of our clients. In this particular use case, we worked with a very big bank in the US, and they had the credit card authorization application running on ZOS, and they wanted to be able to augment that credit card authorization process that they had in place that used static business rules to determine whether a transaction was fraudulent or not, with AI, in order to both decrease the false positives, but also to be able to detect fraud more accurately. Now, this particular client first started doing this by calling out to a distributed server to score those transactions from the ZOS application. But what they quickly found out was that they were getting many timeouts. Most of the time, they had to let the transaction complete without the benefit of AI, because it was too long. It was taking too long for that AI prediction to come back. Even when they did get the prediction back, it would be it would take nearly 80 milliseconds for them to do that. And as a result of those SLA impacts, they told us they were only scoring about 1,200 transactions per second, where they wanted to really score 15,000 transactions per second, so they could score 100% of their transactions. So they worked with us, and actually they brought this machine learning model, LightGBM model. It was a greater boosted type of model. They deployed it on Z, and they were getting consistent response times of 1 millisecond. and they were able to score 100% on their transactions. As a result of that, they told us that they saved over $20 million annually in fraud prevention savings, as well as seeing a positive impact on the revenue that they were seeing by reducing the false credit card declines. They were so happy that they actually implemented the same architecture for the debit card transactions. The second one is actually Visa, which is one of the biggest global credit card providers. And on the back end, they had a batch workload. So unlike the first example I talked about, which was in transaction, real time, online sort of use case, now this Visa example here is actually a batch workload. On the back end, they want to clear and settle all the transactions, and they have a 2-hour batch window which they run this program to actually settle the transactions. And what they told us was they had a very sophisticated deep learning model and LSTM model, for those of you who are versed in the AI art. And what they told us was two things. We want to apply AI to this batch clearing and settlement workload, but we don't want to elongate our batch window. And number two, we want to apply and serve this model the same way we serve AI models on other platforms. So we want to have a consistent deployment environment. And by the way, data scientists know and love TensorFlow and TensorFlow serving. So we want to deploy that model on ZOS the same way we deploy models on our other platforms. So what they've done from an implementation perspective, they actually leverage ZOS container extensions and TensorFlow serving, running in those ZCX container extensions, and then they evoke the model from the ZOS batch application using a REST API in TensorFlow serving. And they were, again, very happy with the scale and the throughput that they were getting, because, again, in their case as well, they had tried to do this off-platform, and they couldn't achieve the scale that they needed. So those are just two examples. Now, I want to highlight a couple more in the next page. I'm going to highlight this instant payments one, because we're working with the European Bank, and what they wanted to do, they've been doing anti-money laundering screening post-processing, but they wanted to bring that in line, especially for instant payments, and be able to do AML screening on every instant payment as part of the core operational flow. And again, they look to Z to be able to do that in real time. The other example is actually a SQL Data Insights example. This example called Gaming the System. In the US, a lot of credit cards have credit card reward programs, and we had this client who told us that a lot of credit card holders were actually gaming or abusing the credit card reward program, and they wanted to introduce AI to be able to detect patterns of credit card reward program abuse and identify those credit card holders so they can notify them, and at the very least, don't offer them any new credit cards or don't approve them for any new credit card applications or offers. And they've done that using SQL Data Insights, that capability that we edit in DBDO, and they were very, very happy. And now they're looking to actually leverage SQL Data Insights for some new use cases as well. And then just for you guys to see the spectrum of use cases that we're seeing on IBM Z and our platform, I'm going to end the traditional AI use cases with my favorite one around climate change impact. We're working with environmental agency here on the EU, where they're scanning aerial drone images to monitor the health of seagrass. Seagrass is very good for the quality of water as well as the marine ecosystem, and this environmental agency wanted to see if there were areas where seagrass was dying so they can put the right ecological measures in place. So that's one of my favorite one, not only building AI capabilities on IBM Z, but actually having IBM Z AI capabilities being used and leveraged to do good for the world. Now, I'm going to switch over in the last 15 minutes or so. I want to talk about where we're going next with IBM Z. I know a lot of you have seen our Watson X announcements around generative AI and generative AI use cases. So now I'm going to focus on generative AI and what are the type of use cases that we're seeing clients solving with generative AI, and what are the capabilities that we're bringing to Z around these newer AI capabilities. So this is a quick summary of what we delivered on Z16, and you actually I have a quote here from Swiss La Mobilier, which is actually the oldest insurance company in the world, and how they leverage SQL data insights to be able to do targeted marketing, right? They wanted to help their agents identify clients that would be likely to be interested in new insurance policy products that they were developing. And what they told us, which was amazing, and you can see here, by using SQL data insights to identify clients that were most likely to be interested in these new product offerings, their agents could achieve 94% accuracy, meaning 94% of those clients they spoke to actually signed up for those insurance offerings, which I thought was very, very interesting to show the power of this technology that we've put in DB2. What we're doing next? Well, we're going to continue to optimize our AI ecosystem, continue to add capabilities to IBM Z as the AI space evolves and as new technologies come into the picture. And some of the things that we're doing here is all about adding foundation model capabilities and really enable you to leverage these capabilities for now, this new set of use cases that AI can solve for. As I said earlier, foundation models is really bringing a new paradigm to AI. Traditional AI models, which is ML and deep learning models, are very good, right, for certain use cases. And for all the use cases that I just talked about, the specialized machine learning and deep learning models are very, very good. Generative AI models are not a good fit for those, in general, for those use cases, only in the cases where you combine non-generative AI foundation models together with traditional ML and DL algorithms can you produce more accurate results. But again, the benefits of foundation models is that you can take this pre-trained model and customize it for any downstream task. Now, I gotta tell you, training this foundation on generative AI models from scratch takes tremendous, tremendous compute, right? But usually what I see most of you will do, you'll take a pre-trained model from a vendor like IBM or from open source like Hugging Face, and then fine-tune or customize that model on your data to solve for a specific use case in a specific industry domain. Now, some of the known issues and things to look out for from a foundational model and generative AI perspective, I talked about hallucination. Hallucination is the term used for when the model generates content that can sound coherent and plausible, but it's all fabricated and it's not accurate, right? And a lot of businesses, certainly, this is a big risk, right? And your reputation can be put at risk. You can actually put your business in being exposed in terms of lawsuits. And I'm sure a lot of you have heard the news about how OpenAI is being sued for really ChatGPT fabricating things. Like they said, one lawyer in the Silicon Valley was actually implicated in an money embezzlement lawsuit, and that wasn't actually true, right? So again, hallucination is a big, big issue with generative AI. Bias in this model. You can have bias in traditional AI models, but that bias is exacerbated in generative AI models, specifically if you don't know what data that AI model was trained on, and if it contains things all over the internet, things from malicious sites, things that contain hate and abuse and profanity and things of that sort. And then explainability. Now, let me say one thing about explainability. Explainability and AI governance is very, very important to IBM because we know our clients, especially our clients in regulated industries, cannot leverage this technology without AI governance. You need to be able to explain to auditors if you're having AI drive decisions, for example, or who's going to get a loan or who's not going to get a loan. You have to really prove that that decision, how that decision was made, and it wasn't made based on bias. So having explainability that explain how the AI model arrived in those decisions is very, very critical. Now, explainability for traditional AI is there and mature. Explainability for generative AI, I will make the statement today that it's almost non-existent. It's very early stages. What you have is the input, then you pass it to these generative AI models, which is 1,000 or 1,000,000 math equations in between, and then you have the output. As a matter of fact, 5 of us can ask ChatGPT a question and it'll come back with different answers, right? So correlating that input to the output and explaining the output of a lot of these generative AI models is very hard. IBM is investing very, very significantly in explaining generative AI models, as well as providing you with tools to mitigate bias and hallucination. And if you are going to use AI models, right, generative AI models in your businesses, you want to ask question is, how was it trained? What data was this model trained on? You want to have transparency and visibility on the training data set that that model was trained on. How can you detect and mitigate for bias and hallucination? Now, at IBM, we have, as part of watsonx.governance, a set of techniques and tooling that would help you to monitor those models all the way from the beginning, looking at the training data sets and trying to remove hate, profanity, and abuse type of data, as well as data that can introduce bias into the model. When data scientists train and evaluate that model, we also have capabilities that can detect bias as well and help mitigate and retrain that model to minimize bias and hallucinations. Some of the techniques that are used to mitigate hallucination is something called retrieval augmented generation, where you actually index a lot of the documentation that you want that generative AI model to draw its answers for, and then you take the prompt or the input that the user provides to that model and you augment it with some of the information from a trusted repository with RAG, or retrieval augmented generation, and then you pass it to the model to guide the model to produce more accurate results. And there's also techniques where you can filter the output before you present it to the user to, again, mitigate and minimize hallucination. Is it transparent? Do you know how the model works? Right? Within IBM, for other models that we provide in watsonx.ai, we are very transparent and disclose how those models work. And then, does it meet regulatory compliance? As part of watsonx.governance, we actually provide capabilities that enable you to have governance and risk and compliance and monitor for all of that. And then, is it safe? I talked about how a lot of these models really need to be customized in order to ensure that you mitigate hallucinations. And can it be customized? How easy is it to customize these models for the specific use case you have for your enterprises? So these are all things you need to consider when you're looking to really leverage generative AI models. So from an IBM perspective, we believe that smaller models, purpose-built for specific use cases, are much better than large models. Also, they're much more manageable in terms of providing explainability. All of our models that we provide in watsonx.ai are open. We share how these models work. We share what is the training data set that we actually used and what data sources and channels we use to train those models. But also in watsonx.ai, we provide a lot of open source models, and we partner with Hugging Face to provide our clients a lot of popular open source foundational and generative AI models as well. And as I said, we believe in trust and governance, because without that, none of this technology can really be deployed in enterprises. And some of the use cases around generative AI, as I said, it's expert advisors or assistants, right, with question and answers using RAG. RAG is this retrieval augmented generation technology that improves the accuracy and really constrains the model in terms of the type of answers and output it produces to stay within that domain, right? So not a general model where you can ask it anything, because that actually increases the risk of hallucination, as well as bias, as well as not being able to have built-in explainability, but really tailor those models for specialized tasks and domains. And some of the use case spaces we're looking at is automation and orchestration, developer productivity. A lot of you have heard about Watson Code Assistant for IBM Z, where we're leveraging this Granite 20 billion model from watsonx.ai to help you modernize your ZOS applications. But you'll see us to continue to actually develop. Right now, my development team is working on an AI chatbot that would allow system programmers and system engineers to ask it questions and increase their productivity, right? You can ask it to generate JCL to submit a job. It can help younger tenures, new talent to our IBM Z platform become productive much, much quicker. And by the way, I know a lot of you have seen the stories of how, well, one of the news stories out there a few months ago was how the Samsung developers actually tried to use ChatGPT to test their non-GA code product that they were working on, and all of their trade secrets ended up in public. Within IBM, we believe that when you fine-tune those models, those customized models belong to you. Your data that you use to customize those models belong to you. And the contents, right, the output that those models generate is your IP and your business assets. So I'll talk about briefly watsonx. watsonx is actually it's made up of three key components: watsonx.data, watsonx.ai, and watsonx.governance. And some of the capabilities in watsonx.data, it provides you with the tools and the techniques to capture and monitor a lot of the data that pertains to certain models. One of the things that we do in watsonx.data, we actually leverage AI models for data quality, to deduplicate the data in those training data sets, to filter them for hate, abuse, and profanity, but also do data cleansing. So we use AI to actually cleanse a lot of those training data sets in watsonx.data. And by the way, every training data set for every model that we've pre-trained, and I'll show you a list of the models that are part of watsonx.ai, you also have visibility to those training data sets, and those data sets have been cleaned and filtered by AI to mitigate bias and be able to remove any hate, abuse, and profanity, even any malicious sites. In addition to that, what we have in Watson.data is a data lakehouse, which brings together, right, the best of a data warehouse and a data lake kind of capabilities, so you can leverage and do AI and analytics using a lot of the open source formats and open source tooling. In watsonx.ai, I'll show you later, we have a set of models that we provide, a set of models IBM pre-trained, AI foundation models, but also we partner with Hugging Face as well as Meta, and you can use any open source foundation model that is on Hugging Face, which is a very, very popular platform for open source AI models, and then Llama 2, which is a Meta and Facebook model. You also find those available on our watsonx.ai platform. And watsonx.governance, that has a governance, risk, and compliance platform to make sure that your AI models are compliant, but also it has all the tooling and the dashboards to help you monitor the end-to-end AI lifecycle. And if we look at watsonx.ai, watsonx.ai is a data and AI platform that allows you to process both traditional AI models, ML, deep learning models, and then it has the additional capabilities of having the right serving frameworks and environments to process foundational models and generative AI models. So for foundational models, we have a model library or a model repository where we provide models that we have pre-trained as well as models from open sources, as I said earlier. Then we have a prompt lab. Prompt tuning and prompt engineering and prompt tuning are really things that relate to generative AI, and prompt is actually the input, right? The question you pass to ChatGPT. And prompt engineering is a technique where you actually fine-tune and craft those questions very well, sort of to guide the generative AI model to produce a more accurate answer, right? So one of the things you can do when I asked it to write a Shakespearean sonnet, right? I didn't just ask it to write any style of poem, but I asked it to write a poem in a Shakespearean style. So prompt engineering is actually a set of techniques where you craft these very sophisticated prompts in order to guide the answers and the results that you get from those models. So we have a prompt lab as part of watsonx.ai that can suggest prompts, right, that can help customize those models to be more accurate for the task you want to actually customize it and fine-tune it for. And then tuning, the Tuning Studio, another way of actually customizing those models is called fine-tuning. Now, with prompt engineering, the model itself is not changed. With fine-tuning, you're actually using a much smaller training data set of your data to customize that model, and actually the model weights change, so you're changing the model itself. And all of that is part of watsonx.ai. In addition to that, for traditional AI, we have something called Auto AI, where you can automate a lot of the model building process by you provide your use case, you provide your training data set, and then this Auto AI capability in watsonx.ai will run a set of machine learning algorithms concurrently and suggest which of those algorithms is most suitable to your use case and would produce the more accurate results for that particular use case. So it sort of automates the building and developing of those AI models to actually accelerate time to value. It also would suggest tuning values that you can provide for that model to produce more accurate results for that use case. So as I said earlier, you can build your own models on watsonx.ai. You can use IBM and open models and models from other third-party vendors and fine-tune them on the platform. And obviously, you can build and tune and evaluate and deploy those models, and these capabilities are available on any cloud. Now, this is a list of a lot of the models, most of the models that are available in watsonx.ai, but the one thing that I really wanted to highlight here is what's highlighted in yellow. And if you are using an IBM pre-trained model like the Granite model that I have on this chart, IBM really indemnify clients against third-party IP claims against any IBM developed foundation model. And that really speaks to the core of our values on how we disclose and we are transparent in terms of the training data that was used to train the models the foundation models that we make available in watsonx.ai. We ensure that no copyrighted or licensed content or material is used to train those models. I'm going to talk about watsonx.data very quickly, but as I said earlier, because we're almost running at the end, 2 minutes of the presentation, you have all the tooling that you need to actually cleanse, and a lot of that tooling is powered by AI algorithms to cleanse and filter the training data that you need to fine-tune or customize AI models to mitigate bias and hallucination. You also have this first-generation data lakehouse, which is really, as I said earlier, brings together the best of both worlds from a data warehouse and data lake perspective, and enables you to do AI and analytics using open source formats and open source SQL query, using open source SQL query engines. And then from a governance perspective, I think you guys are well aware of all the EU AI Act and the penalties, and as you can see there, they're up to 30 million euros or up to 6% of the total worldwide annual turnover for enterprises. So very stiff penalties if you don't comply with the EU AI Act. And in the United States yesterday, President Biden actually announced an AI directive for the safe use of AI within enterprises as well. I want to just spend, from an AI governance perspective, explainability, as I said earlier, is very important. Fairness, making sure that you have equitable treatment of every group, especially if you're going to have AI make decisions that are going to have a personal impact on people, whether it's, as I said earlier, approving them for loans or making decisions whether they should be approved or rejected for certain programs, or even whether they qualify for certain jobs. And robustness is not something I hit on, but let me just say a couple things about what AI robustness means. Now, malicious actors can provide a very sophisticated, crafted input to these models that can cause the model to change its behaviors in terms of the answers it produces, or they can use some really sophisticated, crafted input to have the model reveal the data it was trained on. So that's called data leakage. You want to make sure that the models that you're using are very robust and resilient. So if they see adversarial input, that they don't leak your own private data that you use to train it on, or it doesn't change the model behavior, so it would produce malicious results or answers. And we have tooling in watsonx.governance that allows you to really test for robustness in those AI models that you're going to deploy in your enterprise environments. I talked about transparency a lot, about knowing how the model works, having visibility to the training data sets of those models, and then obviously data privacy is very, very important to us as well. So you have all of those capabilities in watsonx.governance that really allows you to safely use these foundational models and generative AI models safely in your enterprise environments. So let me see what I want to leave you with. We have a lot of use cases that we're leveraging foundational models for on IBM Z. I'm sure you all heard about IBM Watson Code Assistant for Z. And really what I wanted to leave you with, why IBM from an AI perspective, again, because we're open, right, transparent about both the AI technologies and the models that we provide you with, as well as the training data that we use to train those models. We're targeted, meaning we're looking at models that are really targeted to enterprise use cases, specialized models, and everything that you create using our models and our platform belongs to you. And with that, I really wanted to thank you for the time. It's been great being here. And now I'm going to finish this. So to all of you. Thank you.